Welcome back to Reedy's Geometry. This is section 2.5, and I thought maybe I'd better give you a little explanation of what's on your note card. You know, in algebra, whenever we have equations, say an equation with an x and a y in it, we can actually make a picture of that, called a graph. For example, the graph of an equation like 2x plus 3y equals 6 is a straight line. We call it a linear graph. Its picture is a line. Well, in logic, we can also make pictures of what we're trying to talk about with the symbols. The guy who came up with this, his last name was Venn, and so we call these Venn diagrams. That's what Geometry Section 2.5 is about. Let me walk through this note card with you. You have these two circles, and what this represents is a group of things, in this case numbers, and that group we're going to call A. And what's in A? 1, 2, 3, and 4, those numbers. In the group B, what's in there? 3, 4, 5, 6, 7. Okay. Set A, and this little symbol is read or said as intersect. A intersect B. What that means, as the word kind of suggests, is where they come together, or what numbers do they share in common. What do A and B sets have in common from the Venn diagram? Well, they have 3 and 4 in common. So the set A intersect B contains 3 and 4. These are just brackets that they use to sort of set off the things in a set. All right, A union B. Union. Union means all together. So anything in A and in B. That would be these two numbers, those two numbers, and in fact, it'd be all the numbers in this Venn diagram. So A union B set will be 1, 2, 3, 4, 5, 6, 7. That's anything in both A and B at the same time. That is everything in A or B all together. A intersect B, A union B. This is called A prime. And what it means is all the stuff not in A. So what numbers are on this Venn diagram that are not in A? Well, it looks like 5, 6, and 7. All the rest of them are in A. So A prime, or not A, is 5, 6, and 7. All right, now we come down to A minus B. And that would be read as all A that's not in B. So what things are in A that are not also in B? Well, the things that are in A are 1, 2, 3, 4, but 3 and 4 are also in B, so they won't count. The things that are in A but not in B, 1 and 2. 1 and 2. All right. So all of the problems you have to do for this section, they're either going to give you a Venn diagram and ask you questions about it, or they may give you these sets and ask you questions about those. So let's get to some of those problems. All right, these are some problems from section 2.5, and they're going to give us, for these first ones, I'm going to do number 11 first as an example. They give us a Venn diagram. You notice this set called G, denoted by this oval, and inside of it is Z. So all of the elements in Z are automatically going to be in G as well. Then you have this E, set E. All those elements will not be in either one of these others. And they say, well, let the set Z be all the students who play football, E be all the students who get A's in math, and G are all the students who like candy. Now, the way they've drawn this, it looks like there aren't any students who get A's in math that like candy. I think there's something warped about that, but I'm going to go with their drawing. Anyway, and then they're going to ask you a question. The answer to the question will be one of three things. Sometimes, always, or never. It's one of those sometimes, always, never questions that we've seen them before. The number of students who like candy are blank, sometimes, always, or never, the same students who play football. All right, the ones who like candy are G. So that's all of these. If you find yourself someplace in G, will you sometimes, always, or never also find yourself in Z? Well, the fact is it'd be sometimes. You could be out here, in which case you're not in Z, but you could be in here. It won't be never for sure, because if you're in G, you only have two choices here. So sometimes you could be in Z. So that's a sometimes. Sometimes. Same kind of problem for number 12. 12 says the number of students who like candy are blank, sometimes, always, or never. The same students who study in the library. Well, if they like candy, they're in W, and if they study in the library, there's Z. Any place those overlap? No, sure doesn't look like it. So if you like candy, you do not study in the library according to this Venn diagram. So this is going to be never. All right, now we move down to number 17, and they're giving us what we call set notation here. There's no Venn diagram. You could draw a Venn diagram if you wanted to diagram these sets, but let's just go with how it is here. Number 17, they give us a set U. Now, often that set U is called a universal set, which just means it's all of the numbers that could be in any of the following sets they're going to give you. And they give us two following sets. A is 6, 9, and 10, and B is 4 and 9. Now, there are some things in the universal set that are not in either one of these, and that's okay. What they want us to do is to find A intersect B. And if you need to watch a previous video to figure out what this intersect means, you probably should do so. But the intersect is just where they come together or what they share in common. So what elements, what numbers are in both A and B at the same time? And the answer, there's only one of them. That is 9. So my A intersect B set will be 9. We put brackets around it just to denote that that's the element of a set. All right, here's number 21 on your worksheet. And what they do here is they just give you a Venn diagram, the picture, and they want you to use letters to describe the shaded area. All right? So as I look at number 21, I see this box, and that represents U, the universal set, everything in the picture. And then there are two overlapping circles that represent all the stuff in A and B. And what's shaded is the stuff only in B, but not in A. And we have a notation that says in set blah, 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 that's not in set blah, blah, blah. And it's the minus thing. So if I want everything in B that is not in A, that's what's shaded here, then I want B not in A, or B minus A. That's all. They don't have any numbers or any particular elements, so that's just B minus A. Now for number 22. There are actually 3 sets overlapping inside the universal set here. They call them A, B, and C. And look at what's shaded here. It's just this region shared by A and B. C also is shared in there, but we only want all the stuff that's shared in A and B. All right? And that covers all the shading. So I want stuff that's in common between A and B. If I said everything in common in A and B and C, it'd just be this little spot here where my finger is. But I want all of this, so I just want the things in common between A and B. That is A intersect B. And that is my answer for number 22. All right, Venn diagrams.